Hello, it's great to be with you all. Today Okay, it's better. Yep. Today I'm here to talk about with you about something that caught my attention lately, and it's not a popular topic like big data or deploying your Elixir to production like the other talk in the other room, but it's something that you do and we use every day. So what I would like you to take away from this talk is to understand how the SSH works internally. A bit of introduction of myself. I am Milad Rastian. I started using Elixir from 2015 or 16, almost end of 2015, and I wanted to be part of the great Elixir community. That's why I started to work on the Elixir Vim project. If you are a Vim user, I highly recommend you to take a look at it. And then later I moved to Berlin. I am a co-organizer of the Elixir Berlin meetup. We have a regular meetup every second Thursday of the month. If you are in Berlin, make sure you join us and see the lovely community of Elixir in Berlin. And also I started to work in a company called High Mobility. The company is in base Berlin, and we are building a developer platform for connected cars. Before you ask, we do run Elixir in the cars, but those are prototype cars, so it still counts, I would say. And currently we are running a competition platform with Porsche. If you like building application for cars or you have some ideas, make sure you take a look at this competition, and you can also earn some prizes and also get your idea introduced to the Porsche company. We use SSH every day, from pushing a Git commit to GitHub or GitLab, if you will, and we also push our code sometimes if you are using Heroku to Heroku using SSH, and if you are maintaining a backend server, sometimes maybe you SSH to the different hosts for maintaining them. The goal of this talk is to give you an idea of how SSH works internally, so you have better understanding of SSH, and also gives you an idea how to use SSH in your Erlang as a server or client. I divided this talk to two main sections. The first part is about the SSH as a protocol. How does it work? How does the cryptography work? How does the secure connection establish, and so on. And the second half, I talk about the SSH module, the SSH server, and the client, how can use it, and also some unknown feature of the SSH, which is subsystems. I'll talk about them, how to use it in Elixir. SSH, it stands for Secure Shell, but it's an unfortunate name because it's not a shell, but it's a protocol to make a channel between two hosts, having an end-to-end encryption without anyone in the middle of it read the data or interrupt the data. One of the main usage of SSH is, of course, the executing remote shell, but it doesn't stop there. There are plenty of softwares implementing the protocol, and as you see here, the Erlang SSH library, our own Erlang SSH library is there, and also the most famous one is the OpenSSH here. If you want to see the full list of the implementation and see the comparison, what is the difference between them, take a look at this website. SSH itself, as I mentioned, it's a protocol. It includes 4 other protocols that take care of part of the systems. We have the user authentication layer, which handles provide number of authentication, including password and public key, and handles the client. And we have the transport layer, which handles the initial key exchange, setting up encryption, comparison, and integrity check. There is also a connection layer. A single SSH connection can host multiple channels simultaneously, all of them running together and sending data back and forth. as I mentioned, the SSH is included 4 protocols, but the 4th one is a bit also unknown. The idea is about saving the server's fingerprint of public key inside the DNS record so the client can verify the authentication, the genuinely of the server using that DNS, but it's not commonly in use. So if I put all of them together, when the SSH, when user enters the command in the shell, the transport layer initializes the connection, sets up the encryption, the authentication layer authenticates the user, and if the user is valid, the connection layer starts a connection, and then when the user wants to execute a command, it opens the channel to the server and sends the command through the channel. So now that we went through the SSH, if you want to redefine the SSH, SSH makes the network connection between 2 computers with a strong guarantee that both parties of each side is genuine. It also ensures that the data between the data passing over this channel is unmodified and unread by eavesdroppers. So basically, after the setting of SSH, you can send any packet through the SSH. Some people use it for bypassing, filtering, and firewalls, which I used to do a lot. And some people use it to forward the X clients, or of course some use it for just executing commands. Let's go through the history of SSH, because understanding the history gives us perspective, understanding why the stuff work the way that they do today. The SSH was first implemented in 1995 by Tatu Ulund, if I pronounce his name correctly, due to the password sniffing attack in Helsinki, the Helsinki University of Technology network. So most of the thing that we are using came from Helsinki. That's interesting, Linux and SSH. And then there is another group that started the most famous implementation of OpenSSH, which was in 1999. It was until 2006 that both groups wrote the SSH2 protocol, and it becomes the thing that we are using right now. Most of the implementation support SSH2. Some of them are using SSH1 just for backward compatibility. Just looking at timeline, it's quite interesting that until 1995, most of the users were sending data over a network. They didn't have much network, but still sending data through the unencrypted channels. And as you know, Erlang was first released in 1986. And that might be the very reason that the way that the 2 nodes are connecting together is using cookie sending over clear text. So on that time, it was fine. Before going into the details of the SSH, I just go through the cryptographic part of it quickly. It deserves its own topic, the cryptography, but I just try to lay the ground for the part that we need later in the SSH section. The encryption is the process of converting a text to a cipher using an encryption key. We call it cipher. And the way that when nobody can read the cipher or modify the cipher. There are 2 encryption algorithms, symmetric and asymmetric. The symmetric algorithm is a secret key based, so we use same key for decrypting and encrypting the message, the plain text, and you need to distribute the key to be able to unencrypt the data. It kind of not much good for, at least for maybe for our cases, because how would you transfer the key in a dynamic communication like the network-to-network communication? The second part is the asymmetric or public key ciphers. In this category, instead of one key, a key pair, which is public and private, is used. A cipher text that is encrypted by a public key is only able to decrypt using its private key counterparts. You need to keep the private key private, and then you can distribute the public key without worrying about the disclosure. So when someone sends a secret message, they encrypt it with your public key, and you are the only one that can decrypt the message. So The thing is, which one is used in SSH? You might say the asymmetric because of the futuristic of it. But there is a catch. The common public key algorithm is enormously slower compared to the other one by order of magnitude. And it's infeasible to encrypt the large quantity of data using the public key ciphers. For this reason, modern encryption uses both of them, combines them together. So just quickly see how it would work. If Alice wants to send a message to Bob, Alice will create a random key and then encrypt the plain text that she wants to send to Bob using that random key, and then later she encrypt the public key. She encrypt the random key by Bob's public key and send it over the network. Now no one is able to read the data because of the encryption, and also the speed of the public key algorithm is not a problem because a small amount of data were encrypted. Now on the other side, Bob reversed the process and can read the data back. This method have the advantage of both systems, and in fact SSH uses some technique like this. User data crossing and SSH connection is encrypted using a fast secret key, and the key for which is shared through the two parties using the public key methods. The last section that we are going to talk about in the cryptography, then we go to the internal of SSH, is Defi Hellman algorithm. It's quite interesting. The way that it works is it generates a shared secret key between two parties without sending it over an unencrypted net connection. Each party uses its own private key and the public key of other one to come up with the session key. And surprisingly, these two keys that they come up are the same. I'm not going to prove it to you mathematically because it's hard and takes time. But instead, you see how does it work with the colors. As I mentioned in the previous slide, SSH uses both of these techniques, and actually the way that it comes up with the session key is using this method. You can take a look at the colors while I'm drinking water. So now it's about the SSH and how does it work, how does the encryption work, and other stuff. Let's briefly take a look at the components inside the SSH. We have the client on one side, which is a program that connects to the server, of course. It sends the command like give me uptime, or these are my git commits, put it somewhere. And we have the server, which allows incoming SSH connection, handle authentication, authorization, and so forth. We have the session in the middle, which is started after the connection has been established and user is authenticated. And we have the user key, which is the key pair of public and private key. User uses his own public key as a way to identify itself to the other party, and ASCII also have a key pair. It uses the public key of it to identify itself to the client. So that's sometimes for example, if you just bring a server and try to SSH to it, and later you destroy the server and bring it up again with the same IP, you see that the SSH doesn't allow you to connect directly to the other side. It says the key doesn't match. That's the way that it knows. It keeps the public key of the server that is already connected inside its own file to make sure that no one can switch the server. Or if it happens, you know that it's happening there. So when this is almost the interesting part. That's the part that magic happens, and I hope that you can read it. The way that a secure connection is established. When SSH client connects to SSH server, everything in the initial step, everything's passed over using the clear text. Actually, if you just do telnet or netcat SSH server, you see that the server immediately returns its signature. That's the way that they are going to work. So the client connects to server, it says, I want to connect to you, and server immediately sends back the signature of the server, and also the version that the protocol it supports. Here it says, I am Erlang, I have implemented SSH2. And now it's the client turn to decide if it's the match for the client. If it's a match, it sends its own signature to the other side, and server also checks if everything is fine. If this initial handshake is approved by the server returns list of encrypt algorithm that it supports, and also it sends a large random number back to the client. Now the client and server both use this random number as a seed to create a key pair. This is a temporary key pair. It's not the same key pair that the user has. And then later they exchange the public key together. Still, this is a public key, everything is fine, even if someone is listening to the connection. And now each side separately uses their own private key and the other side's public key, and use the Defi Hellman algorithm to come up with the shared session key. And after that is done, as part of the SSH protocol, the secure channel, they turn on the encryption, and you have the secure connection. After the secure connection is established, user needs to authenticate itself to the server. There are multiple mechanisms of doing that. The one that more interesting is the common one, or I would say, is the password authentication and the public key authentication. Password authentication is quite simple. The SSH connection that exists is encrypted, so the user can just give the password to the client forward it through a secure channel to the other side. But the thing about the password authentication is not that much secure. Even though the connection is encrypted, but it might be that the server is compromised, and by entering your password, you are sending the password to the other side. The other option, which is the public key, is not like that. Even if the server is compromised, still you don't send your private key on the other side. So that's one of the advantages. So let's check the public key because it's more interesting. The public key authentication uses the public key cryptography to verify the client's identity. The server has a list of public keys inside. Usually it goes to the root directory of the user.ssh/authorized keys. And when it connects to the server, it tells the server, I want to authorize myself using this public key. It sends the ID of the key, which is the fingerprint of the key. And the server checks the target's icon authorization, see if that public key exists in that file or database if it's using more advanced version. And if there is a matching key, and then if it's correct, the server generates a random key and encrypt it using the public key that it exists in your database and send it back to the user. Now, if the user really claims that it has the key pair, it should be able to decrypt the message and send it back. But it doesn't work exactly like that. The thing is not secure just to send the key back again. So what happens is the SSH client, if it really has the key pair, it will unencrypt the message and then concatenate the random string with the session key that it has, and calculate the MD5 and send the MD5 to the server. And the server calculates the MD5 itself. It is the match. The user is grant access to the user. The last layer to review is the connection layer. So in this layer, all the requests for the services on the remote machine should be made over channels. That makes the SSH protocol a bit complicated maybe. A single SSH connection, as you see, it can simultaneously have all of these channels open, simultaneously working on over the connection. As you see here, each channel represents the processing of a single service, so we have different services running using different channels. When you invoke a process on the remote shell, it will open a channel for the invocation and then send all the inputs and outputs related to that channel through that on that channel. The connection itself just handles packets of channels in the different that has open. So it means, for instance, in a single SSH connection, you can have a process to execute a command, and at the same time, download a file through SFTP and forward a number of the ports simultaneously, all happening in the single connection. But naturally, they don't happen simultaneously, but rather work in the timeshare fashion to share the bandwidth connection of the bandwidth of the connection. But as I mentioned, it makes implementing working with the SSH protocol a bit more complicated. We will see when we are implementing a SSH client. You need to do some extra stuff that maybe doesn't tick, but if you understand the protocol, you understand it's required. So now that we have better understanding of the SSH, internal of SSH, let's see how can we use it in your Elixir application. Erlang comes with a full-fledged SSH module that can be used as a SSH server or client. It uses OpenSSL crypto library to encrypt the communication. Before digging into the code, there are some configuration that we have to make. These are the necessary level of the SSH. We need to configure the server keys. So here, later we can try it from this slide. I also have it in GitHub. You need to create the key pairs for the algorithm that your server wants to support. Usually, these are the three ones that if you want to support most of the clients, you can use these three. But if you are the only consumer of the SSH server, I suggest to stick to the top one, which is creating a key pair using elliptic curve algorithm. If you want to know why it's better, you can take a look at this link, which is an article by Cloudflare. And I'm sure you trust them, they take care of all of the security of our servers. We need to add the SSH into the running application as well, and the configurations are done. Running a simple SSH server is quite simple, nothing fancy. You need to mention the sys directory, which is the directory that you keep your server's private key. It should be secure, of course. And as you see here, I also provided the user password that I want my client to check my client against to. And I want to run in port 22. The return value of this one is OK, PID, or error, and there isn't. If you want to run it in your production, probably you want to supervise it properly. Running the basic server is quite simple. Here it asks me for the password, and then I get by default I get access to the Erlang shell. It's still not optimal, but it's good enough. What bothers me is keeping the password, because you need to manage the password and everything. It's annoying. So let's see how can we build SSH server using public key. That's also quite simple. We need to just provide the user directory, which would be the place that you keep the authorized _ keys. And here I explicitly mention I don't want to check again. I don't accept the password authentication. So it just asks for user to get the public key directly. And here, as you see, first time I tried to SSH to the server, to the service, it didn't allow me, and then I copy my public key into the authorized key, and it works again. The daemon function of the SSH module accepts long list of options that it's better if you go and check through the documentation. But for example, here I added a few, I add some of them that are more interesting, like disconnect function, connect function, and fail function. These are functions that you can use to log some incidents or release your resources and so forth. And here also, this is how you receive the logs. But let's see how can we access to an Elixir share. It's more interesting than putting codes around the modules. It's also quite simple using different callback or function. You just pass the shell, it sends the username and pair to you, and you just say IX start. Now you have an Elixir shell. The problem that I have with this one is exiting this shell, because if you say system exists, it will turn off your Elixir application. Also, Control C doesn't work, so I couldn't figure out how to come out of this one. I usually just kill the SSH client. The extendability of the SSH goes much further than what we have seen so far. One interesting feature that I found useful is using callbacks to handle SSH public key authentication. So you can use your custom data, and instead of looking at the public keys inside the file, you look at the database or third-party API to authenticate the user and check the public key. So what I would like here is to use, if you know how the GitHub API works, whenever you put your public key inside the GitHub, your profile page, there is an API that I can extract your public keys from there. Public key is public, so no one should panic. That should be fine. So when the SSH connection connects to Erlang, instead of looking at the file, I want to call an API to GitHub and check if I can access the server. So first, there is one thing that we need to do, additionally as the configuration. We need to implement a module that implements behavior of the SSH server keys. It has two functions that you have to implement: the host key, which returns the list of public key of the server. I'm not interested in that one. I just go and do the default one, you get it from the file. But the other one is the isAuth key. This accepts few parameters, and what it does is return a true or false. True means the public key exists, we accept this public key, and false means this public key is not acceptable. Fetching user from public key is quite trivial, nothing here. But just one thing, just to be clear, it's not just checking if the public key exists in our database. As I mentioned before, when we give OK to the SSH module that this public key is a valid one, it starts sending a challenge random number to the client and make sure that the client has the private key part. Configuring the SSH server is also quite simple. You just say the option is key CB, which stands for callback, and you give the module, it will call your module later. As you see here, I tried to SSH to my localhost using my GitHub account. It worked, and then I tried to connect to SSH using Joseph Alim's account. It didn't work because I don't have his public key, private key. If you have laptop here, we can have some fun. I already in this server, there is a SSH server running. If you would like to connect for a few minutes. We can have a chat there. Hi. Jello. Can you? Nice. Okay. So the reason that I got interested into the SSH in the first place was because I wanted to write an application like a GitHub or GitLab, if you will. And I wanted to experience how the system works because it was so historically I work in 3 different companies that they moved from SVN to Git, so I was somehow part of onboarding process, helping people to pick it up. So I have the Git dear in my heart. I also used to work as a sysadmin, so I also like SSH as well. And in our company, High Mobility, we use a lot of encryption and make sure the data are encrypted. So all of this got my interest, and also to dig in how the SSH works. This is the project that I was trying to do, the clone of or copy of the GitLab. It never get off the ground because I couldn't decide about the JavaScript framework for the UI. That was surprising. But what I end up with working SSH server that can accept the SSH, can accept the Git commits and Git fetch and all the features. So here I try to extract the Git and SSH section of it. It's a Git server which uses SSH currently. You can handle authentication of your user through calling your database and so forth. So let's see how does the SSH client works, and it's simple again. So here I tried to SSH to my server, but it accepts the SSH password. I didn't enter the right password, it canceled it. Let's use the public key here as well. It should be simple. So here I said that I don't want to offer the password, so the server or the client that never asked the password from my UI. This is a client section. And I said I want to use user root here. The first one is just initializing the process connection reference. Then, as I mentioned, if you want to execute a command through to a remote server, you need to create a channel. So here is the channel part. It opens the channel from a channel 0, and then I can send the command uptime. This is an OpenSSH server, so I can execute the shell commands. And then it will return success. All of the messages that sends back the response of the uptime came back to the current process. You will see it here. It will receive the data, and immediately in this kind of one-time execution, it immediately closes the SSH channel. So if you want to send another command, you need to create another channel for that. That part make it a bit hard or confusing at the first. Why do I need channels? The last section of the SSH module that I want to cover is SSH Subsystem. It's mostly undocumented part of the abstraction of SSH protocol that I just found it while I was reading the Erlang documentation, so it's good for something. And it's good for invoking a custom command through the SSH. You might already using SSH Subsystem, for example, when you SFTP files through the SFTP of the file, it uses the subsystem there. Implementing the subsystem is also, if you know the callbacks, is simple. Here I implemented echo subsystem. So what it does is the client sends a string binary of data, and then the server returns back the same data to the client. Most of them are boilerplate, but the most interesting part is this section, that it receives a data in the channel, and we will send the same data back through the same channel. As you might already guess, the subsystems are so it's easy to configure. So here I said I want to identify this subsystem as echo, and this is the submodule that has this implementation and some probably parameters. And the client part is also, I need to do the initialization of the connection, create a channel as before, and then mention that this channel is supposed to use the subsystem echo, and then I send my data to the other side. And how it works in action is quite trivial as well. Here I run the server, and here I just send the data. I said, what did I say here? From the previous one. I say, is there anybody out there? And it replies me back. This looks simple, but you need to think about it, come up with the crazy ideas, what you want to do with it. One of the examples that I spent too much time thinking about, what can I do with it? So one of the examples that I thought that we can do is, at least in our company, we have something called a vault system that keeps the data securely using the encrypt the data, and then everyone wants to get the data needs to provide the proper data. Mostly it's the interface of it is for internal system. One possible solution would be just go crazy. You can your subsystem can accept GraphQL probably, because GraphQL only have one entry, and then it receives the command, process the data, sends the data back to your client. Your data is super secure, military grade secure, so it's good to use in this kind of situation maybe. Or maybe if you have a nerve project, instead of you want to talk to it sometimes for whatever reason, instead of bringing a REST API, you can use this one, your subsystem to talk to your nerve project and maybe get some valuable data back. Actually, the nerve in the previous talk, we heard that Nerve's framework SSH is something for updating the framework in Nerve, and actually it uses subsystem for that reason. Here are the list of references and the further readings. The first one is a book. It's for 2005, but it's really good, and it's really definite guide. You can understand a lot of internal of the SSH. And the second one is the Erlang SSH module, of course. It's a bit maybe hard to understand, but if you know the context, it's easy to read the documentation. There is a ESSHD, which is a customized SSH server written in Elixir. It's really good for, maybe you don't want to use it directly, but it's really good to go. Sorry, Siri. Yep. So it's a SSH server that you can read. Maybe it gives you idea how to use it. There is a SSH Key client from BitCrowd. It's also make a lot of boilerplate stuff simple for you. And of course, the last one is the SSH tunnel. As I mentioned, you can even forward the ports and do a lot of crazy stuff with SSH. This project is doing that. You can get some idea how to do it. And by that, thank you.
Okay, hello. Okay, so we've got 7 minutes for questions. Has anyone got anything interesting you want to ask?
Hi. I wrote a few weeks ago a similar project for writing a Git platform using built-in SSH, and I got a step further and wrote the Git transfer protocol in Elixir with a lot of binary pattern matching, which is funny in quotes. And I wanted to ask if you know any drawbacks regarding raw speed when transferring lots of data for big Git clone or Git push, or maybe concurrent work when a lot of clients connect to the same server, and do you know if there are any benchmarks or any restriction I should?
I didn't reach that point, unfortunately. My project failed because of the using JS framework. I mean, finding the right JS framework. Yeah. But The thing, what I've seen is when you create a process, it opens a channel. When you open a channel, it creates a process. Everything happens through the process, and I believe it's one of the advantages of the Erlang, the Beam, is if you have a proper data properly sent over through different processes, it take care of the system. So,
okay.
It's in, yeah.
But you don't know any benchmarks that have been done?
No, I didn't. Right. Maybe we can take a look at together and find some.
Yes.
Yeah.
Thanks.
Any other? Okay.
What would be your, when we're talking about distributed systems and they are far apart, different data centers, and you said that we cannot communicate because safely because it uses the secret cookie that goes, I guess, almost easy to break. What would you use in order to have a distributed system that they can talk to each other? SSH,
Yep. So,
or
the thing is, on top of my head, I don't have a definite answer for you. Sorry, but what I can think is you can build your own network on top of internet. So you have your internal network of the servers, even if they are from different part of the world. You can make, for example, IPsec or OpenVPN connection, make a network around them. Then it's more secure compared to the other one. But still, the thing is, no one suggests using Erlang node over WAN. So maybe we should wait until the core project is supporting that. Even though you can secure that through the VPN, it's not suggested still because of the latency should be really low for the two nodes who can communicate properly.
Okay, thank you, Milad. Round of applause.
Thank you.